All right, guys, Mr. Antonucci here, and in this video, I want to walk you through an example of how to use U-substitution with definite integrals. Now, I'm going to show you two methods. You can kind of pick which one you want to do. Both of them work equally as well as one another, but I think they're both pretty cool. So check this out. We want to find the definite integral from 1 to 0 of 4x over the quantity 1 plus x squared cubed. So remember, when we're doing U substitution, you want to first define what your U is, and typically it's going to be the inside of the function. So in this case, U equals 1 plus x squared, and then our du is going to be 2x dx. Now that almost lines up with what the numerator is here, except it's off by a factor of 2. So what we could do is multiply both sides of this equation by a factor of 2 and get that 2 du equals 4x dx. And now we can do our substitution. You're going to write the integral. The 4x dx is replaced with 2 du. And the 1 plus x squared is replaced with u, so it's u cubed. Now, I'm going to leave the limits off because the original limits are in terms of x, and now I'm switching the problem to being in terms of u. So technically speaking, the 0 and 1 as the limits would be incorrect. But we will bring those back in a couple of minutes here. So I could rewrite this, factor the 2 out, bring the u up as u to the negative third power, du. And now this is just a power rule problem. You add 1 to the exponent, which would give you negative 2. I wrote negative 3, but there, we fixed it. Negative 2, and then multiply by the reciprocal, the new exponent, which would be negative 1/2, multiplying the 2 that's already there, and you'd have negative 1u to the negative 2, which would be negative 1 over u squared. Now at this step, you want to back substitute what u is and then introduce the limits again. So it would be negative 1 over 1 plus x squared, quantity squared, evaluated from 0 to 1. Now we're going to plug in 1 first, so negative 1 over 1 plus 1 squared, quantity squared, minus the function evaluated at 0. So it's negative 1 over 1 plus 0 squared, quantity squared. And the denominator here in the first one, 1 plus 1 squared is 2, 2 squared is 4, so that's negative 1/4, minus, now right here you'd have negative 1 over 1 squared, which is negative 1, so it's minus negative 1. So essentially we have negative 1/4 plus 1, which is 3/4. So I'm going to write 3/4 up here as our answer. And now I'm going to show you really quick the second way to do this. The second way is you do the u substitution until you get to the antiderivative. So I'm going to erase everything up to the antiderivative because we already did that. The second method does all of that the same. And here's what we do with the second method. I'm going to do it in blue. What you do is you change the limits to be in terms of u. Remember, u is 1 plus x squared. So if I take the upper limit and plug it into there, I would have u equals 1 plus 1 squared, which is 2. In the lower limit, which would be u equals 1 plus 0 squared, which is 1. So now I can take my negative 1 over u squared and evaluate it from 1 to 2. Now you're going to get the same answer, but now we just leave it in terms of u because we don't need to back substitute in terms of x because we switched the limits to being in terms of u by using what we defined u to be. So if I plug in 2, I'd have negative 1 over 2 squared minus -1 over 1 squared, which, lo and behold, you'd have -1/4 plus 1, which is 3/4, and that corresponds to what we got the other way. Now, you don't have to do the problem both ways unless your teacher or your professor says show both ways. You could pick one or the other. Just don't mix them up. If you leave the limits in terms of x, you have to back substitute your antiderivative in terms of x before you plug the limits in. If you switch the limits to being in terms of u, then you evaluate the antiderivative in terms of u. All right, that's one of the common mistakes that I see students make is they'll mix the two methods up. So just be careful there. All right, guys, that's it for this video. Hopefully it was helpful to you. If you do have a math problem that you'd like me to make a video on, you could drop it in the comments below and maybe I'll make a video about it. Make sure you subscribe to the channel and hit the bell for notifications when new videos are uploaded. That helps me out a lot getting these videos out to other people. All right, guys, take care. Thanks.